Okay students, so till now we have discussed about the last samples, means when the sample size is greater than 30. But when the sample size is less than or equal to 30, then also we need to test the hypothesis, means the statement whatever we have considered, how far it is true, that we have to test. So as we know that here the small sample means the sample size must be less than or equal to 30. So in these small samples we have a students t-test for single mean, difference of means and paired t-test. Apart from this we have also the f-test for variances, that is difference of variance, and chi-square test for single variance. But in today's class we are going to discuss about the students t-test for single mean, difference of means and paired t-test here. So where we can apply this students t-test for single mean here. First, suppose here if I want to measure the particular length of a product, right, and here the samples are of size less than or equal to 30, whether all the samples are meeting their specific measurement or not, so that we have to test. There we can use this small sample test for single mean. And whenever we are just comparing the two products, whether they are meeting the specifications or not regarding the size, means here the data is measurable here. So whether they are meeting the specification or not, so that we have to test here regarding the two different populations, then we use the difference of means. But when we consider the sample, and for the sample here definitely the sample size is less than or equal to 30. For the sample, when we are applying the before and after techniques here, so is there any difference between the after and before applying techniques, that we have to test. So for that we will use the paired t-test for difference of means. So here for the students t-test for single mean here, the null hypothesis is as usual just like the last sample, that is mu equal to mu naught, means the mean of the population is equal to some specific constant. Again as the alternative hypothesis here, it can be a two-tailed, that is mu not equal to mu naught, or it can be a one-tailed, that is mu less than mu naught or mu greater than mu naught, that is less than means left-tailed and greater than means right-tailed here. Then under the null hypothesis, the test statistic is given by two formulas here. So first one is here x bar minus mu by small s by square root of n minus 1 follows a t distribution with n minus 1 degrees, right. So whenever the independent observations are given and the observations are also repeated twice or thrice, right. If I want to find the average mark of the class here, right, so simply I pass the statement that the average mark of the class is out of 40 it is some 35. And how far my statement is correct, that I have to test here. So for that I have considered a sample of only 20 students, because here we are discussing about the small sample, right. So those 20 students marks I have taken. So there is no particular rule that here for the 20 students the marks are different. So here the two of the students can get the same marks here. That means here the observations are repeated. So those 20 students marks I have taken, that is independent samples we can see. So whenever the individual observations are given here, then we have to use x bar minus mu by small s by root n minus 1. So this follows a t distribution with n minus 1 degrees. So we know that x bar is the sample mean, mu is the population mean, and here small s is nothing but the sample standard deviation. So whenever the individual observations are given, that can be obtained using the calculator under regression linear mode. Then when the direct data is given to us, that means here instead of the 20 students marks, they have given the mean marks of those 20 students directly, then we have to use the formula t equal to x bar minus mu by capital S by root n here. So this also follows a t distribution with n minus 1 degrees. So here the observations can be repeated, so that's why it is 1 by n minus 1 we have taken root over, and there the observations are not repeated, so that's why it is capital S by root n. That is the only difference we have. Then we have to obtain the tabulated value of t at n minus 1 degrees for the corresponding alternative hypothesis. So if the alternative hypothesis is here not equal to, that means two-tailed, then we have to look after the table value at 0.025 for 5%. That means we have to divide it by 2. And if the alternative hypothesis is two-tailed for 1%, then we have to look after the table value at 0.005. That means 0.01 by 2 we have to take here. And if it is one-tailed, then again here we have one-tailed means it can be a left-tailed or right-tailed here. So when it is left-tailed here, then we have to look after the table value at 0.05 only, but before the table value we have to place a minus sign. But when it is right tail, that means greater than here, then we have to look after the table value at 0.05 and the tabulated value will be plus only, right? Then the next one is the t-test for difference of means. That means here for the same branch, when we are talking about the two different sections of the same branch here, then obviously the null hypothesis will be mu1 equal to mu2. That means here there is no significant difference between the average performance of those two sections, means those two sections are equally here. Then again as an alternative, it can be two-tiled or one-tiled, that means either less than or greater than. Then the test statistic is given by the formula x1 bar minus x2 bar by capital S into square root of 1 by n1 plus 1 by n2. So x1 bar is the mean of the first sample and x2 bar is a mean of the second sample, and capital S is estimated by the formula here square root of n1 into small s1 square plus n2 into small s2 square by n1 plus n2 minus 2. Either you can calculate capital S square and there you can obtain the square root of that, or directly you can write capital S equal to square root of n1 into small s1 square plus n2 into small s2 square by n1 plus n2 minus 2. So this is small s1 square and small s2 square are the sample variances of the individual samples here. So for both the samples we have to take the common sample mean square, that's why that is capital S equal to the formula. Then we have to obtain the tabulated value at n1 plus n2 minus 2 degrees of freedom for the corresponding alternative hypothesis. So that is about the difference of means. But when we consider the sample, and for the sample when we are applying some techniques just before and after, right, means here we can take a very clear example about the students of our college. So when we are conducting the exams here, so before mid 1, right, we will see the performance of the students in weekly test, and those whoever are slow learners, so for them we will conduct some revision test. Then after that we will allow them to write for mid 1 here. So before revision, after revision, we will identify the difference here for the same slow learners, right? So for that, whenever we have to face the situations like that, then we have to use the paired t-test for difference of means. So then also the null hypothesis is here mu1 equal to mu2. That means there is no significant difference before revision and after revision. Then again as the h1 is here, it can be a two-tiled that is not equal to, or it can be one-tiled that is less than or greater than. Then the test statistic is given by the formula t equal to d bar by capital S by root n. So this follows a t distribution with n minus 1 degrees here. Now this d bar is nothing but the average between the marks of before and after, right? So before revision, after revision will be there. We have to find the difference of those, and the average of those difference is nothing but here d bar. So that can be, even if we take the difference between the marks in a calculator, so that can be obtained d bar under regression linear mode. And capital S is given by 1 by n minus 1 summation of di minus d bar whole square here. So that can also be obtained using calculator. Then you have to compare the calculated value with the tabulated value at n minus 1 degrees here. Then here coming to the conclusion of the problem for the single test or difference of means or paired t-test here. So we have to look after the table value for all the three tests like this only. So the top represents the level of significance, and here this vertical part represents the sample size here. So here the samples are defined from 0 to 30 here. For suppose the sample size is here 11, then we have to look after the value at 11 minus 1, n minus 1, then 10, and if it is 5%, one tilde, then 0.05. So the coincidence value is a tabulated value. So just for the example, we have taken one value also. So 10 degrees means sample size, and the level of significance is here 0.1 and 0.05, right? So the coincidence value is your tabulated value. Then here for the conclusion part, right, then if the null alternative hypothesis is here not equal to two-tiled, then if the calculated value is negative, we have to consider modulus of that. So if t-cal or modulus of t-cal is less than or exactly equal to t tabulated, then the null hypothesis h0 is accepted. Then if the alternative hypothesis is left-tiled, means it is less than, and if t-cal is negative here, you are not supposed to consider the modulus of that, right? So if t-cal is negative, then the tabulated value is also, before that we have to place minus. Then if t-cal is less than t-tab, then h0 is rejected. But if Tcal is greater than Ttab, then H0 is accepted. So that is a reverse condition we have to use here. So for all the things, for the right tiled and for the two tiled, the conclusion is same only. If cal is less than tab, H0 is accepted, and if cal is greater than tab, H0 is rejected here. But for left tiled t test here, if the Tcal value is negative, then Tcal is less than T tabulated, then H0 is rejected. And if Tcal is greater than Ttab, then H0 is accepted. And regarding the right tiled, that means for greater than alternative hypothesis, the condition is same, just like the two tiled only. Okay, so this is about the t-test for single mean, difference of means, and paired t-test. So remember, whenever for the same sample they are using the two situations, then we have to use the paired t-test for difference of means. Okay, so just now we have discussed about the test statistic for single mean, difference of means, and paired t-test for small sample. Now let's see the problems on small sample for single mean here. So a mechanist is making engine parts with axle diameter of 0.7 inch. A random sample of 10 parts shows a mean diameter of 0.742 inch with standard deviation of 0.04 inch. Compute the statistic you would use to test whether the work is meeting the specification at 0.05 level of significance. And the tabulated value of t for the 9 degrees is given as 2.262 here. Okay, so we have discussed the applications of this small sample for single mean, that whether whatever the items we are producing are meeting the measurement specifications or not. So that's what here also they are asking you to test here. So you may get a doubt that here they have mentioned the mean diameter of the standard deviation, but a mechanist is making engine parts with axle diameter of 0.7 inch. There the average is not mentioned. So you may get a doubt that the test is regarding mean or not, right? So when the mean and the standard deviation are given and they are asking that whether the work is meeting the specification, then definitely the basic test we use is the mean test here. So if you go on to the solution here, the null hypothesis is here H0 mu equal to 0.7 inch. Then against H1 here. So in this problem, you just observe any comparable words are given or not. If there are no comparable words, then the alternative hypothesis will be two type. So in this problem, we have no comparable words here. Just simply they are asking test whether the work is meeting the specification or not. So nothing is mentioned here, whether it is meeting the specification or not, greater than or less than like that. So here alternative hypothesis will be two type, that is mu naught equal to 0.7 inch here. Okay. Then under the null hypothesis, the test statistic is given by the formula t equal to x bar minus mu by capital S by root n follows a t distribution with n minus 1 degrees. So here directly the x bar value and the mu value are given. The independent samples are not given. So we have to use the test statistic t equal to x bar minus mu by capital S by root n here. Right? Now if you see the given data, the sample size is given as here 10. Mu value is we know that is 0.7. And x bar value is given as followed by the sample size. The mean value is given as 0.742. With the standard deviation of here, it is given as 0.04. Now substitute in the t formula here. So t equal to x bar minus mu means 0.742 minus mu value is 0.7 by capital S is here 0.04 by square root of n means n means here 10. So first we simplify that. 0.742 minus 0.7 is 0.042 by, so root 10 is here 3.16. So 0.04 by 3.1623. It is 0.0126. So that means the t calculated value will be 0.042 divided by 0.0126 is 3.3333. So the t calculated value is 3.3333. Now the t tabulated value at n minus 1. N minus 1 means here at 10 minus 1 is equal to 9. For the level of significance is given as here 5%. For 5% level of significance for two-tailed here, because the alternative hypothesis is here not equal to. So for two-tailed, that means we have to look after the table value at 0.025 under 9 degrees. It is given as 2.262. So that means here T cal is 3.3333 is greater than T tab. So H naught is rejected. H naught is rejected, that means here we are accepting H1. That means here the mean diameter of the axle is not equal to 0.7 inch. Right? So H naught is rejected means here we are accepting H1. So therefore mu is not equal to 0.7 inch. Let's see the second problem on this single bead here. A random sample of 10 bags of pesticide are taken whose weights are 50, 49, 52, 44, 45, 48, 46, 45, 49, 45 in kgs. Means they are weighed in kilograms here. Test whether the average packing can be taken to be 50 kgs. So here the question is very direct. Test whether the average packing, means it is the test for single bead, and moreover they have taken a sample of only 10 bags, means which is less than 30. So it is a small sample test for single bead here, and the tabulated value is given as 2.262. Now first let us frame the null hypothesis H naught as mu equal to 50 kilograms kgs, right? Then against the alternative hypothesis H1. So here also in this problem there are no comparable words. So mu is not equal to 50 kilograms. Then under the null hypothesis, the test statistic is given by the formula T equal to x bar minus mu by small s by root over n minus 1. So this follows a T distribution with n minus 1 degrees. Now here the individual observations are given. Then we have to use the test statistic as small s here, because here the observations can be repeated also. So if you see here 45 is repeated twice, right, and 49 is repeated twice here. So whenever the observations are repeated here and they have taken the independent samples, then we have to use the test statistic as x bar minus mu by small s by root over n minus 1. Okay, then now here for these samples we have to obtain the value of x bar and small s here. So that can be obtained using calculator. Right? Now the given data, the sample size is 10 and the mu value is given as here 50. Now first of all we have to store these values under regression linear mode. Right? So for regression you have to press the mode key for 2 times. Then under the second option you have regression, press the second option. Then you will be having the 3 options here. In the first option is linear, means linear data we are taking here. Now one by one you just give the observations here. So the first observation is 50 m plus, that means first observation is stored. Next 49 m plus, second observation is stored. Then 52 m plus, then 44 m plus, 45 m plus, 48 m plus, then 46 m plus, 45 m plus, 49 m plus, and the last one 45 m plus. So n equal to 10, that means the 10 observations are stored in the CALC. Then press the ACE and press the shift 1, right? So we need the summation x for x bar formula here. So the summation x is here 473 and summation x square for finding the smallest value. So for the summation x square it is here 22437. Okay. So here we have written small x bar, so here also we have to use a small x only. Okay. Then here we know that the x bar formula is 1 by n summation x here. So that also can be obtained using calculation by pressing shift 2. First option is here x bar, which is 47.3 here. Means 473 by 10 is nothing but 47.3. Now the smallest formula is here square root of summation x square by n minus x bar square. So this also can be obtained using calci and shift to second option that gives you the value of small s here. So this is 2.531H. Now substitute the values in the T formula here. Now P equal to x bar means here 47.3 minus mu value is here 50 by small s is here 2.531H. So 2.531H by square root of 10 minus 1. So square root of 10 minus 1 is nothing but 9. So square root of 9 is here 3. So 47.3 minus 50 gives you minus 2.7 by 2.531H divided by 3 here is 0.8439. That means the T calculated value is here 2.7 divided by 0.8439 gives you 3.1994. But here we have minus, so minus 0.3.1994. Now here our alternative hypothesis is not equal to means 2 times. So we can consider the modulus of that. So that is 3.1994 here. Now the tabulated value of T at here n minus 1 means the sample size is 10. 10 minus 1 is 9. At for 2 times means here the alternative hypothesis is here not equal to. So for 2 times at 5% level of significance. Now here nothing is mentioned about the level of significance, then by default we have to consider 5%. So at 5% level of significance is given as here 2.262. So here mod T cal is 3.1994 and T tabulated is 2.262. That means mod T cal is greater than P tab, so therefore H naught is rejected. H naught is rejected means here again we are accepting H1, that is mu naught equal to 50 kgs. So that is the conclusion for this problem. That means the average packing cannot be taken as 50 kgs here. Now let us see one more problem here. The heights of 10 beds of a given locality are found to be 70, 67, 62, 68, 61, 68, 70, 64, again 64 and 66 inches. Is it reasonable to believe that average height is greater than 64 inches? Test at 5% level of significance. The tabulated value is given as here 1.833 for 9 degrees of freedom. Right? Now if you see the question here, the question is very direct. Test whether the average height is greater than. That means this is the test for single mean. That is the small sample only, because here the sample size is 10. So H naught is here mu equal to 64 inches, because always the null hypothesis should be an unbiased statement. Then against H1. So here clearly it is given that greater than is a comparable verb. So it is here one tile, that is right tile, mu greater than 64 inches. Now under the null hypothesis, the test statistic will be P equal to x bar minus mu by small s by root n minus 1 follows a T distribution with n minus 1 degrees, because here the individual observations are given to us and moreover some of the values are repeated also. Now here the sample size is 10 and the mu value is directly given as 64. Now for x bar and small s, again we have to use the calci, that is regression under linear mode here. So the values are here 70, then 67, 62, 68, 61, 68, 70, 64, again 64, and the last one is here 66. Now press the shift 1, second option, we will get the summation x, which is here 660. Now again press shift 1, first option, we will get summation x square, which is here 43,650. Okay, now we know that here the x bar formula is summation x by n. So for that, let's shift to first option. We will get here 66 because here 660 by 10 is nothing but here 66. And the formula for small s is here square root of summation x square by n minus x bar square. So for that, let's shift to second option. So it is here 3. That means 43,650 by 10 is here 4,365 minus 66 square, under square root it is here 3. Simply it is 3 here. Now substitute in the t formula x bar minus mu. That means 66 minus 64 by standard deviation small s is here 3, square root of n minus 1. N means here it is 10. So 10 minus 1 means 9. Square root of 9 is 3. So 3 by 3 is 1. And here the numerator is 2. So 2 by 1. That means t calculated value is here 2. Right? Now the tabulated value of t at 10 minus 1 is equal to 9 for one tile. Because here the alternative hypothesis is here greater than. So it is one tile. So one tile and that too that is greater than, that means right tile. And level of significance is here given as 5%. So the tabulated value is here 1.833. That means in the tables we have to look after the table value at 0.05 for 9. So it is 1.833. So t calculated is 2 and t tabulated is 1.833. That means t calculated is greater than t tabulated. So therefore H0 is rejected. H0 is rejected means here we are accepting H1. That means mu is greater than 64. So we are accepting that the average height is greater than 64 inches. So that's about the problems on single beam for small sample.